Welcome to NerdOut at Spotify. I'm Dave Zolotusky, Principal Engineer at Spotify, and this is another Release Notes episode, where we'll focus on a single feature and what went into building it. Today, we're talking about how we translate podcasts into other languages using AI to generate the original speaker's voice. This feature is called voice translations, and the first prototype was built over a weekend. Then, just 6 weeks later, the team was already shipping episodes of Lex Fridman's podcast, with Lex and his guests speaking in Spanish. We have Spotify's Sandeep Ghael here to tell us how the team did it. Well, Sandeep, it's great to have you on. Can you just tell me a little bit about yourself and what you do at Spotify?
I'm Sandeep. I'm an engineering lead at Spotify, and I lead our generative AI and large language modeling efforts. Large language models certainly in generative AI is having a moment. So what it means in general is like we have essentially new AI technology that is more capable than we've ever had. And this really has some profound implications for how we build products at Spotify and just generally how the world does its work. So here at Spotify, we use this technology to help understand our talk content, which is like podcasts and audiobooks. But we're also finding more and more ways to use generative AI to build new experiences for our listeners.
I gotcha. So most, if not all, work Spotify does with generative AI goes through your team now?
We're kind of the tip of the spear, I would say. We've definitely been early in the personalization mission, which is where I work on using language modeling to understand our content, mostly for personalization and recommendation reasons. It's been a really good tool for helping to create essentially what we do with music, which are like music vectors, which help describe music and help us recommend music. We're now trying to recreate that magic of giving really amazing recommendations for talk content with similar understanding of our talk corpus or podcast. And so that's how we've sort of been in the driver's seat on a lot of these efforts at Spotify.
That's cool. You're not the first person I've asked to do this, but since you mentioned music vectors, can you quickly tell me what are music vectors?
The music vectors are this amazing way that we can mathematically describe music. And that has a lot of really useful applications, especially when you're using computers and algorithms to recommend music. So it helps us basically understand the different dimensions of what a piece of music might be. It's either upbeat or it's energetic or it has a lot of guitar. It has perhaps a certain style of vocals. So all these things can be described in some essentially mathematical way that can then be inputted into an algorithm that can help recommend things to users.
All right, so let's take a step back then. You told me a little bit about your role. Tell me a little bit about how you got there.
So I definitely didn't study machine learning. My background is actually electrical engineering and signal processing. I've always been extremely fascinated with music. I would say music is the reason I became an engineer. I wanted to build synthesizers. And so I studied signal processing. After graduate school, I worked in the field as a signal processing engineer, building audio algorithms. And then more recently, I basically had an opportunity to start getting into machine learning. I was an early lead at Amazon working on the Alexa product. So I worked on a lot of speech and voice technologies there. And from then, it was a short jump into large language models, which is where we are today. And what's really interesting to me is, obviously, this is in the realm of computer science, but so much of the math that underlies a lot of this large language modeling work is linear algebra. And it's all the same math I studied for electrical engineering.
Yep. That was not my favorite college class, but I get it.
Yeah, full circle.
Cool. So let's jump into some of the stuff you're doing more recently. I think one really cool thing that came out of your team recently is a voice translation feature. Can you just tell us a little bit about what that is and maybe a little bit about the process of putting it together?
Yeah, that was a really interesting product because we've been toying with this idea of how do we create more distribution for podcasts by porting podcasts into new languages. And it's something that's been tantalizingly close for a while. And we've certainly seen some creators do this manually. And we felt like this was something that we could do for podcasts. And a lot of the pieces, especially around generative AI, have really started to come together in the last, I would say, year. So we have the capability to transcribe content automatically using speech recognition technology. We have the new capability of generating voices. Those voices have been kind of not so great for the many years. You know, you can think of like the computerized Alexa voice or like Google's Home voice. And they're not something you would want to listen to for an hour of a podcast. And then furthermore, it's not really true to the creator if we use that artificial voice. So what felt like it was a sort of missing ingredient in this whole recipe of porting podcasts to new languages was, how do you stay true to the original creation and actually use the original creator, the host and the guest, their actual voices in a new language? And obviously we need to be able to translate their words into a new language and still make sense in that language. There's all the cultural nuances of translation that matter. I think this is probably, for me, one of the more fascinating parts of the problem, which is translation is not just straight translation of words. It's actually like translating something so that it's culturally appropriate, it's idiomatically correct. And then for us, especially because we're doing podcasts, we're not translating books, we're translating conversations. And there are all these like unique nuances of translating a conversation that matter. So all of these pieces needed to come together, and it feels like we just recently have arrived at like the generative AI technology to unlock this.
And I guess you would say that technology is all of those pieces. It's like the translation is much better, as well as the kind of nuances of the speech are much better because of this new technology.
And the transcriptions are better so that you actually understand what the original podcaster was saying. Yeah, all of these things have just been uplifted in the last, 18 months quite a bit. And I think the thing that we did, which I think was really cool, was recognize that these pieces were approaching a level of quality that you could compose them all together and build this new experience.
Yeah, that's really cool. Because I was going to ask, how different is it really from just doing a translation, like obviously a good translation, like some leading edge translation process, and then just running it through something like a semantic kind of real true voice speech? And it sounds like it is pretty different.
Yeah, it's quite a bit different. So one problem we're fighting right now, and we're making really good progress, is gendered speech. So in English, you really don't have like gendered words, but if you go into a language like Spanish, there's gendered speech, and you have to actually keep that consistent throughout the entire conversation. And we're actually trying to use language models to solve that problem. Language models have this surprising capability of maintaining context over long periods of words and sentences, and maybe even hundreds of pages of context, perhaps. So we're employing every trick in the book like that to try to actually make the conversation in English make sense to somebody listening in Spanish, and they don't have to wince at some inappropriately gendered noun or a weirdly non-idiomatic phrase.
Tell me a little bit how this came together. I mean, it seems like once you kind of saw all the things you just said, turning that into a feature was actually surprisingly fast from your team.
I think there was two things that happened. So one is building a very initial prototype. And when I say like prototype, it was literally me hacking on a Saturday and pulling together all the sort of component parts that I knew existed already at Spotify, our ability to like transcribe at a high level of quality, our ability to do machine translation pretty well. And then we had this like recently available technology to do voice cloning. And it was sort of this interesting new technology we had from OpenAI, which was the ability to do one-shot voice cloning, which was really different than other voice cloning technologies we had available. For a lot of machine learning, there's this concept of supervised training. That's really the traditional style of machine learning, where you basically give the model hundreds or thousands of examples, and then it learns based on the examples. Some of these models have become so smart and sophisticated, especially in the realm of language models or transformer-based models, that they have almost like world knowledge to some extent. And you can basically just give it one example, or sometimes even 0 examples, and tell it to do a task, and it will already sort of know how to do that task pretty well. A classic example here is machine translation. You can ask a large language model, translate this sentence from English to French, and it'll do a really good job. It wasn't specifically trained to do translation, and you actually didn't even prime the model that you were going to give it a translation task. But the fact that it could do it on the spot is this concept of zero-shot learning. Typically, to build a good voice, you might have to train a model for many hours on lots of data. But this model we had access to actually allowed us to just give it a few seconds of source audio, and it was able to model a voice very quickly. And this was really beneficial in a podcast context when you might have multiple hosts and you actually don't know who the next host will be in the next episode. And then furthermore, the variety of voices you might hear in a single podcast might be like 4 or 5. So our ability to actually feed our really high transcripts and a really high translation through this voice system ended up providing this like really compelling proof of concept demo. And we just ran it through one episode and we wrote an RFC. RFCs at Spotify are basically documents, requests for comments, where you can basically publish an idea, blast it out to the larger community at Spotify and have them give their comments on what they think of your idea. So an RFC was written around this. We laid out the fact that we could do this. We actually demoed this up top in this RFC and actually said, like, this is actually what it sounds like. I thought that was the most important part. Just listen to it before actually reading, like, how it actually works. And it caught the eye of some, important tech leaders here at Spotify, including people like Gustav, who leads our technology strategy here. And he was really enamored with this idea. And I think from there, we basically had some executive buy-in to move really fast and build the thing for real.
So you got executive buy-in to move quickly. And then what happened? I'm really curious how you even were confident that it was really working and it would work at higher scale.
Yeah, that was definitely a bit of nervousness there. We knew we could do this for a certain style of podcasts, particularly like very turn-based conversational podcasts. Lex Fridman was our sort of classic example here. He speaks for long periods of time, but then he stops and he lets his guests speak for long periods of time, and they take very distinct turns. And we knew this process may break down for more complicated podcasts where people talk over each other, where they may have more effusiveness and might have laughter and joking or irony even. And so we basically had to think about how to solve a lot of these problems. And to be clear, we haven't solved all of them, but for a large category of them, we were able to find a process that automated many of these things. Sometimes we use humans in the loop to facilitate and make sure the quality bar is really high because we want to be true to the original creator's voice. But the process of building that was basically pulling together a small group of engineers, usually people who are domain experts in various parts of the system. I was the language modeling expert in the room. We also had people from our Speak team who are the voice synthesis experts. And then we had experts providing transcripts as well. We had the localization team, which really were critical in making sure that we maintain high level of quality throughout the process and doing some manual review of the final outcomes.
With things like localization, I'm really curious how that even worked. Like, it sounds like you mentioned them in the context of ensuring that the things that were translated made sense in the new local context. But if they didn't, then what?
Early on, we knew that we were moving so fast and this was such a new technology that we needed some guardrails. And the best guardrails we could have were human experts in the loop, making sure that what we were doing, the final output, made sense. And so very early on, we basically had this localization team reviewing our early renders. We would render a podcast, we would send it over to localization, they would grade it, and then they would send their notes back to us. And so we had this basically feedback loop stood up very quickly where we were able to quickly understand where the errors were in our system, and we would try to programmatically fix it. In some cases, if we weren't able to programmatically fix it, let's say there was a transcription error and it just wasn't going to be able to be transcribed properly, we would fix it manually and then flow it through the rest of the automated system. But this feedback loop was super critical because it essentially exposed our weaknesses very quickly, and visibility into the weaknesses was the most important element for us to be able to move fast and fix things.
I think one thing that we keep hearing a lot about with these large language models is things like hallucinations and kind of places where they might create nonsense. Tell me a little bit about how that impacted this work. Like, did that happen here? Did you magically avoid it? Or did you have to create systems to know when this was going on?
Oh, this is really interesting. So we did have hallucinations, but they weren't from the large language model. They were actually from the voice synthesis engine. Now, the voice synthesis engine is a similar architecture to what you might imagine like a stable diffusion image generation model is. So it basically, in this case, synthesizes the audio basically from noise. It's this really interesting denoising process. But the model we were using to synthesize voice was, while it was really good when it worked, it would often hallucinate. And hallucination in this context is not that it would say a word that you didn't expect it to say. It more sounded just like garbled junk. It sounded like a word, but it was just like a mumble. And so you were listening to this podcast, and then all of a sudden you were expecting a word and you just got this blurry mumbling sound. So we had to solve this problem, this hallucination in the voice model. And we found a really clever technique for doing that, which was actually using another machine learning model to detect the hallucinations. And when we did detect those hallucinations with this other model, it would actually literally just try to take the synthesized audio, transcribe it. And if it wasn't able to transcribe it, it would be like, I didn't understand that. You should probably re-render that piece of speech. We would then essentially re-render it, but we would tweak some parameters so that the diffusion process was more likely to succeed.
I gotcha. So you would effectively take the podcast, transcribe it, run it through all of your systems, and then if what came out the other end was untranscribable back, then you would know that the speech hallucinated some nonsense noise you would need to then regenerate.
Exactly. Yeah, it was a really clever technique that the Speak team was able to come up with. And this is all in the context of like this intense 6-week sprint. So we were discovering these problems. We would have these moments where we're like, oh no, how are we going to solve this? And then we would have to come up with some brilliant MacGyver solution in typically 24 hours and move on.
Yep, but it worked every time.
Yeah, at least in this case it did.
Are there kind of exciting next things you're doing with this, or?
Absolutely, yeah. So what we delivered was a pilot program for a few podcasters, and we know that the output we're able to create for these podcasters, like Lex Fridman, is very high, and we're really super excited by that starting point. But the next challenge is definitely taking this to different types of conversations. There's lots of humor podcasts, comedy podcasts rather. There's lots of podcasts where they're way more conversational. People talk over each other. We also want to go into different languages. So far, we've really only gone into Spanish, but we want to make these podcasts available in other languages as well. So all of these dimensions add more complexity on the problems we have to solve with our dubbing machine system. That's what we call it, the dubbing machine.
How far are those things once you have the basics working? Are these like super different things to get other languages, other types of podcasts? Or is it working the hard part and now it's just minor tweaks to add the rest of it?
What's interesting, I think, with a lot of these types of problems in engineering in general, but I think especially machine learning, is the gains become harder and harder. So you can get to an 80% solution pretty quickly. And 80% might be shippable, and a lot of people might experience the 80% solution really well. But then to get to 90% is that much harder. And then to get to 95% is even harder. And so I think we're at that point in the curve where we're really trying to get that last 15%. And that's going to be a journey. We're going to need new technology breakthroughs, either in the language models, our ability to interpret the content, our ability to transcribe it, our ability to synthesize it, our ability to provide a wider vocal range and emotional range with the final output. We think we can get there, and the technology is moving at such a fast pace of innovation. That's going to help us along the way, but it's going to be a journey to get to like that 100%. This is as if the creator created it in Spanish, for example.
Awesome. Thank you so much. It's been great having you on.
Awesome. Thank you, Dave.
Outside of this LLM stuff at work, what other things do you nerd out about?
Well, Spotify is an amazing place for me to work because I nerd out on music all the time. I'm a big music nerd, especially hip hop and techno. I got into this entire world of engineering because of wanting to build synthesizers. So I just really like going deep in the Spotify catalog and discovering stuff. And it's so cool to me to think that the algorithms that we're building here at Spotify are actually helping me discover music and scratching that itch for myself.